Hello there. The last video we talked about z-scores, and I said that I'd go over how to do the reverse of finding a z-score, that we would talk about the formula for going from a z-score to a score. The formula for this is x is equal to z times our standard deviation plus mu. This should be familiar in terms of what all these components are from our last video. If they're not, go ahead and take a look at it. Once you've caught up on what all of these mean, let's go ahead and begin calculating. We don't know what x is, so we have to leave it alone. We'll just say x is equal to, we know that our z-score, if we pull in the page from last time, we had a z of 1.62. We're going to multiply that. I'm just going to put it in brackets so it's clear what I'm referring to here, by our standard deviation, which again, going back, was 3.7. And then we're going to add mu, which, looking here, was 7. So that's step 1. Go ahead and separate out step 1 and 2 with a little bit of this. And here we are with step 2. So x is equal to, we're going to deal with our multiplication first, 1.62 times 3.7 is equal to 5.994 plus 7. And so as you can see, for our third and final step, we're just going to add those numbers together. Plus 7 is equal to, so x is equal to 12.994, which rounds to 13, the score that we had. Now, I don't want you to think that you can only do this for scores that you are using in your data set. We can calculate this for scores that we don't have. So if we wanted to pick out something, and let's say we wanted to find out what value would be 2 standard deviations above the mean, or 3 standard deviations above the mean, because that's an indicator of when something's an outlier. At least it's a standardly accepted procedure to eliminate scores that are 3 standard deviations above the mean as outliers. So let's go with that instead of 2. So we're still looking for x is equal to, we're taking our z, so let's go with 3.00 times our standard deviation, which is still 3.7, plus mu, so 7. We're going to go ahead here, separate our steps. Remember to mark this as 1. Go ahead and mark this as 2. We're going down here. We still have x is equal to, but this time we're going to multiply 3 times 3.7 is equal to 11.1 plus 7. And you don't really have to go on to step 3 just because of how simple these numbers are to work, but we will just for the sake example. So x is equal to 18.1. So a score of 18.1 would be 3 standard deviations above our mean, and would be in the range where we would consider ourselves justified in eliminating it because it's an outlier. Although there is some finesse to the topic, as there's always the case that that could just be an extreme score, that they're not an outlier, it's just an extreme score. But that's something that you'll have to decide based on your data and your population and what you're studying, and I can't give any advice on that. So there you go. That's how you find the score that corresponds to any z-score that you can think of. I hope this has been helpful for you. Let me know if you have any questions, and you can find all of this linked down in the description.